According to studies, approximately 80% of all accidents are caused by human error. There are many different reasons for human errors to occur. Here are some of them. Ignorance of job hazards. Lack of understanding or skill in how to work safely around hazards. Carelessness. Recklessness. Task versus safety focus. It won't happen to me attitude. Risk assessment is the overall process of risk analysis and risk evaluation. In other words, it is the investigation of what in your work could lead to an event which may cause harm to people or property, so that you can weigh up whether you have taken enough precautions or if you should do more to prevent an accident from occurring. A risk is the combination of the likelihood of an event to occur and the consequence of the event. In other words, a risk is the chance, high or low, that people or property will be damaged because of a hazard. Almost everything we do on board includes risks. Therefore, all tasks on board have to be analysed for potential dangers. Risk analysis forms part of the risk management process. It involves identifying the risks and determining the likelihood, or probability, and consequences of each risk. When analysing risks, we have to first identify the hazards that can create the risks. Then we have to estimate both the likelihood and the consequence of the event. A consequence is defined as the outcome of an event. There can be more than one consequence of one event. The consequences can have economical and/or human nature. There are different ways of determining the consequence of an accident. Here are some examples. Modelling, making either a computerized or theoretical model of an accident scenario. Incident history, looking back at previous accidents to see what consequences they caused. Examples of consequences: damage to humans, injuries or death. Environmental damage, pollution, property damage, damage to your own ship, other ships, cargo, equipment or shore facilities. When professional risk analyzers do a risk analysis, they put scores on the consequences. Please study the table for examples of scoring consequence. The first step in any risk assessment is to identify the hazards that create the risks. A hazard is anything that has the potential to cause harm. In the marine environment, we have a variety of hazards present. Here are some examples of potential hazards. Weather, such as sea, wind, fog, heat, cold, snow, etc. Inadequate lighting. Unsecured objects in a moving seaway. Damaged tools or equipment. Chemical hazards, fumes, contact. Working at heights. Inadequate ventilated spaces, especially enclosed spaces. Unsecured openings. Handling heavy weights. Slippery surfaces. Electrical hazards. High-pressure medium, such as steam, gas, etc. Moving or rotating machinery parts. High noise level. Likelihood is the extent to which an event is likely to occur. When professional risk analyzers do a risk analysis, they put scores on the likelihoods. There are different ways to determine the likelihood of a risk developing into an accident. Here are some examples. Incident history, such as looking back to see how often accidents have happened in the past. Model analysis, such as making a theoretical model of the job to estimate the likelihood of an accident. Component failure rate data, such as asking the manufacturer of equipment how often it breaks down. Please check out the table for examples of scoring the likelihood. After you have calculated the scores for the likelihood and consequence, you will have to evaluate the scores. Entering the scores into a risk profile matrix does this. Here are some examples. The risk for a tanker to explode. The risk for you to stretch your back when lifting something. Risk management is the coordinated activities to direct and control an organization with regard to risks. Risk management generally includes risk assessment, risk acceptance, risk treatment. Risk assessment, which is the first step in any risk management process. Risk acceptance is the decision whether to accept the risk or not. If the risk is accepted, you work with the risk. Risk treatment is the process of selection and implementation of measures to modify risks. Risk treatment measures can include risk reduction, risk mitigation, risk avoidance, or risk transfer. Risk acceptance is used in risk management to describe an informed decision to accept the consequences and likelihood of a particular risk. Based on your risk profile matrix, you have to decide if a risk is acceptable or not. If you end up in a green field, you can accept the risk and continue working like you planned. If you end up in a yellow field, you should think about reducing the risk before continuing. If you end up in a red field, you must reduce the risk before continuing with your work. Risk treatment describes the part of risk management in which decisions are made about how to treat risks that have been previously identified and evaluated. Options for risk treatment may include risk reduction, risk mitigation, risk avoidance, or risk transfer. Risk treatment is also known as risk control. Risk reductions are actions taken to reduce the likelihood of an occurrence, its consequences, or both. Risk mitigation is the limitation of any negative consequences of a particular event. Risk avoidance is an informed decision not to become involved in activities that lead to the possibility of the risk being realized. Risk transfer is used in risk management to describe the shifting of the burden of the risk to another party. Insurance is a common example of risk transfer. The risk management process. Identify all risks involved in the job. Estimate the likelihood of the risk and rate it. Estimate the consequences of the risk and rate it. Enter your scores into the risk profile matrix. From your matrix, you will find out if the risk is acceptable. If it is acceptable, continue with the work. If not, you will have to go through the risk treatment procedure and then restart at risk identification. To reduce a risk, we have to either reduce the likelihood, the consequence, or both. After the risk reduction, you have to do a new risk analysis and enter the new scores into the risk profile matrix to be sure that you have reduced the risk to an acceptable level. One way to reduce the likelihood is by decreasing the number of times the task is performed. If this is not an option, we will have to implement other measures. Here is one example. You must clean the outside of the bridge windows every morning. The likelihood for you to fall down is high. One way to reduce the likelihood is to clean them only once a week. This is not an acceptable alternative, since it will result in another risk, the risk that the bridge personnel will be unable to see through the windows. Another way to reduce the likelihood is to install automatic window wipers. A risk can also be reduced by minimizing the consequences of an event. Let us continue with the cleaning the bridge windows example. Without any safeguards, the consequence of falling down to the deck can be death or disablement. Wearing a safety belt will reduce the consequence to a lesser injury. Sometimes there is a better or less hazardous way to do a job. Often engineering revisions can be done to create a safer work area, or work-saving tools and equipment can be used to make a job safer. Adding an anti-slip surface to the gangway steps and deck walkway is one example of an engineering revision. Using a special hand trolley to transport 200-litre drums that could be moved by hand is an example of a work-saving tool. Deciding which jobs can be done differently involves determining the goal of the work and then analysing the various ways to reach the goal to see if any of them offer safety improvements. If a new, less hazardous way to do the job cannot be found, physical conditions should be studied carefully. At times, the physical conditions, the tools, materials and equipment that create a job hazard can be changed. These conditions can be corrected through engineering revisions. Consider this example. Company statistics indicate several injuries have occurred while handling heavy loads of spares and stores delivered to the vessel in large wooden boxes. To correct this condition, an engineering revision is required to break open the spare parts box on the vessel's deck, check the contents of the box, and then transfer the individual parts one by one from the deck to the spare parts locker. If hazards cannot be engineered out of a job, sometimes job procedures can be changed. For example, a job procedure might be changed to ensure that the flow of hot oil within the fuel system or steam within the steam system is stopped, and that the system is depressurized before work is attempted on the various pieces of equipment. This would allow the fuel oil system or steam system to cool down and depressurize. Always be careful when changing job procedures so that you avoid creating additional hazards. If the job changes are too difficult, long or uncomfortable, you or your co-workers might be tempted to take risks or shortcuts to avoid them. In some situations, the frequency or regularity of performing a job can be reduced. This is often the case with hazardous maintenance jobs requiring frequent service or repair of equipment. By asking what can be done to eliminate the cause or condition that makes the excessive repair or service necessary, the repetitive need for a job can be reduced. For example, taking local temperature readings on the main engine could be reduced to once a day in order to minimize the risk of slipping and falling when climbing around the main engine. Additional remote readings could be obtained and printed several more times per day from the engine control room. The use of personal protective equipment should always be the last consideration in reducing the hazards of a job. It's always better to control hazards by administrative or engineering revisions. But engineering revisions may take time to design and install, and changes in physical conditions may have to be engineered. Obtaining new, better, or additional personal protective equipment normally requires only minimal time and effort. Proper personal protective equipment, identified through the risk analysis process and by using your own common sense, should always be worn throughout the duration of a job. The effectiveness of your personal protective equipment depends entirely on your willingness to use it faithfully. For critical operations on board, we have procedures to follow. These procedures have most likely been developed by the use of risk management, done the formal way, including use of the risk profile matrix. For all tasks you perform on board, you should follow the outlined procedures, but you should also use informal risk management. It is impractical to carry a risk profile matrix with you when working on board at all times. Therefore, you should get used to doing informal risk management in your head before taking on any task on board. It works in the same way, but without pen and paper. In this next activity, you'll be presented with two different versions of the same scenario involving Ben and John, two crew members in the deck department. Listen to each scenario and determine whether you think they successfully applied informal risk management when performing their job task. John, we've got to move that life raft to the forecastle and place it onto the cradle before sailing.
Sure, Ben. Let's do it.
We should hurry up, as we've also got to sort out the rest of the stores we receive. You know, John, we've done this job so many times in the past, it's a piece of cake. If I take one side and you take the other, we'll have this craft back in its cradle in no time.
We'll do it on 3, okay?
Did Ben and John use informal risk management when doing this job? Okay, 1, 2, 3. Oh! Oh! My back! The life raft was far too heavy for 2 people to carry. Fortunately, Ben was not seriously injured, though the back strain he suffered required that he did light-duty work for the next week. This unfortunate incident happened because Ben and John did not use risk management before doing the job. Now let's take another look at this scenario. Hey John, we've got to move that life raft to the forecastle and place it onto the cradle.
Yeah, okay. How are we going to do it?
I was thinking we'd use the deck trolley to move it from here to the forecastle.
Okay, but I think it might be a little too heavy for the 2 of us, don't you?
Yeah, I agree. Let's get a couple more guys to help us out with this one. Why don't you call Jason and Mark and then pick up 2 wooden wedges from the workshop?
Okay, Ben.
We can use the wedges to secure the rear wheels of the trolley while we're lifting the life raft. In the meantime, I'll get a piece of rope we can use to secure the life raft to the trolley so that it doesn't slide and fall off while we're transporting it to the forecastle. The vessel is rolling a little. After a few minutes, John returns and Mark and Jason join them. Ben inserts the 2 wooden wedges under the rear wheels of the trolley. Okay, Mark, you'll be on my side. John, Jason, you 2 stand on the other side. Did Ben and John use informal risk management this time around? That ought to do it. Good job, guys. Now the raft is ready for transportation. Let's move it forward and place it in its cradle. By taking the extra few minutes to assess the risks of the job and take the appropriate measures to reduce them, Ben and John, with a little help from their crewmates, were able to get the job done without incident. If we all take the time to complete an informal risk management, we can reduce the risks of accidents and create a safer work environment. Here we will use the same example as we had in the informal risk management. Ben and John shall move a life raft from the gangway and place it in a cradle on the forecastle. We know that the job involves lifting of heavy equipment, so we can say that the risks involved are risks for back injury of people lifting, risks for injuries by dropping equipment, risks for damaging equipment by dropping it. Through experience, we can estimate that the likelihood for these things to happen is as follows. Risks for back injury of people lifting is estimated to happen at 1 lift out of 200, 0.5%, gives us a score of 4. Risks for injuries by dropping equipment is estimated to happen at 1 lift out of 5,000, 0.02%, gives us a score of 2. Risks for damaging equipment by dropping it is estimated to happen at 1 lift out of 2,000, 0.05%, gives us a score of 3. The consequences will be estimated as follows. Risks for back injury of people lifting can lead to lost time caused by back problems, gives a score of 2. Risks for injuries by dropping equipment can lead to repatriation or hospitalization, gives a score of 3. Risks for damaging equipment by dropping it can damage the life raft. Cost of life raft is less than $1 million, gives a score of 1. We have to enter the scores for each risk in a risk profile matrix. From your matrix, you will find out if the risk is acceptable. If it is acceptable, continue with the work. If not, you have to reduce the risk and then restart at risk identification. By using a trolley, we can reduce the risk for back injuries. If a trolley is used instead of carrying the raft, the likelihood will be reduced to 2. When the new number is entered into the matrix, we can see that the risk is reduced to low. By adding 2 more men to the job, we can reduce the risk for dropping the raft. If 4 persons are helping each other, the likelihood will be reduced to 1. When the new number is entered into the matrix, we can see that the risk is reduced to low. In the next couple of pages, you will be presented with 4 different accident scenarios. For each scenario, see if you can identify the most likely cause of the accident. A crew member uses the overhead crane to lift an exhaust valve spindle from the grinder. Having never done it before, he guides the valve spindle out of the grinder with one hand while operating the crane controls with the other. During the operation, he loses control, and the valve spindle, weighing about 100 kilograms, swings and hits him on his head. After a gangway wire jammed, 2 crew members attached a manual crank handle to the winch so they could wind it manually. An officer doing his rounds noticed that the gangway wire was tight. Not being able to see if anyone was working on the winch, the officer went to the control panel to operate the winch. In attempting to do so, he caused the manual crank handle to swing around, breaking the arm of one of the crew members. A crew member was attempting to drill a hole in an 8mm thick piece of metal sheet. Like he'd done many times before, he used the handwise grip to hold the sheet under the drill bit. When the drill bit penetrated through the metal sheet, the force of the rotating drill twisted the piece of metal. Consequently, the crew member's wrist was severely twisted, almost breaking his hand and causing severe bruising. A crew member was descending a flight of stairs while carrying a rolled-up fire hose with both of his hands. The vessel was rolling slightly, and the stairs were wet from a previous hosing down. The crew member lost his balance and fell down the stairs, hurting his lower back and one of his hands. As you learned from the scenarios, all the accidents were caused by human error. Understanding how and why accidents happen is the key to their prevention. What's needed is an ability to recognize the hazards and apply good common sense when working around them. To prevent accidents, we have to analyze the risks involved before performing a task. The idea is to heighten awareness of safety issues and get people to think and talk about job hazards and how they can be controlled, so that every job is completed safely.